Lesson 2 is set up similarly to Lesson 1. First we'll talk about multiplying whole numbers in money, then dividing whole numbers in money, and then we'll talk about fact families dealing with multiplication and division. You can think of multiplication as adding the same number several times. For example, maybe we had 21. We wanted to add that 4 times. 21 plus 21 plus 21 plus 21. That would equal 84. We can get the same result by multiplying 21 times 4. So there's 4 multiples of 21. That's how you could think about that. 21 times 4. Now if you recall, when you multiply like a 21 times 4, you multiply the 4 by 1, and then you multiply the 4 by the 2, and that would be an 8. You get 84 for an answer, just like you should get the same number as you did when you added 21 4 times. Otherwise, you did something incorrectly. Now in multiplication, the numbers that you multiply together, those are called factors, and the result of the multiplication is called the product. Remember in Lesson 1 we learned that the result of addition is called the sum, the result of subtraction is called the difference. Multiplication, the result of multiplication is called the product. Now in our example, 21 times 4, we multiplied the 21 by a 1-digit number. We multiplied it by a 4. What if we multiplied it by a 2-digit number? Let's think about that. We did 21 times 14 instead of 21 times 4. We basically multiply the 21 twice. Once by the 4. 21 times 4, we just said that was 84. And then once by 10. Now think about why that is. This 1 here, that's in the tens place, right? So what we've done is we've broken up that 14 into a 10 and a 4. And so we do 21 times 10. That's easy. We can just say 21 times 10 is 210. So we write 210. And now we add this result together. Now we're doing addition. We did 2 multiplications. 21 times 4 is 84. 21 times 10 is 210. And we add the result of that together. 492. 294 is our answer. We give a special name to those 2 numbers that we added together, the 84 and the 210. We call those partial products because they aren't really the actual product of that multiplication, right? They're partial products. They're part of the product. Now let's try a multiplication problem involving money. 15 times 28 cents. Now let's rewrite this vertically. Remember, the order doesn't matter in multiplication. We could have written this 28 times 15 or 15 times 28 like we have. And we're multiplying 15 by a 2-digit number, so we'll have 2 partial products that we'll add together to get the final product. First, let's do 15 times 8. 8 times 5 is 40, so we have 0, carry a 4. 8 times 1 is 8, plus 4 is 12. So 15 times 8 is 120. Now let's do 15 times 20. And if you wanted to, you could do that over to the side. And these numbers will always be like factors of 5. 20 is a factor of 5, and those are usually pretty easy to do. You can just think of 2 times 15, that would be 30. And then add that 0, 300. 20 times 15 is 300. So let's add that partial product. And so we add those together, and we see that the answer would be 420 cents. Now, if we want to change that to dollars, and that's how we want to write our answer, we move the decimal place over 2 places, right? 1, 2, and then we change it to dollars. $4.20 is what we can write as our answer. Let's try one more. Let's do 0 times $1.53. Now, any number times 0 is 0. So always an answer like that or a problem like that, the product will be 0. Anytime you multiply another number by 0, the product is 0. Let's try one more multiplication problem. This one will be a little more complex. Let's do 208 times 33. Let's rewrite this. Again, we could have done 33 times 208, but it'll be easier to do it this way, right? If we did 33 times 208, we'd have to multiply 3 times. We do 208 times 33, we just have to multiply twice. And so 208 times 3, let's do that. 8 times 3 is 24. Carry a 2 there. 0 times 3 is 0, so we just bring a 2 down. And then 2 times 3 is 6. And then we have to do 208 times 30. So we could write that over to the side. And remember, one thing you can do on problems like this is leave that trailing 0 over to the right side, and you just add that later. And so we'll do 208 times 3, so that's 6240. 6,240. We just added a 0 there. And so let's put that over here. And now let's add those two partial products together. 4, 6, 8, 6. 6,864 is our answer. Now let's talk about dividing whole numbers in money. Now we do division when we want to divide a number or separate a number into equal parts. For example, if we wanted to separate 24 into 3 equal parts, we do division. And there's different ways we write that. We can say 24 divided by 3. We could say 24 over 3. Or we can use a format like this. Now in each case, if we divided 24 into 3 equal parts, the answer would be 8. We write that in these locations just like we did there. And just like in addition, subtraction, and multiplication, we have some special names for the different numbers and where they're located. The result of division is called the quotient, and then we have the dividend and the divisor. The one thing that can be confusing about division is there's so many different ways that you'll see a division problem written. Like here we have these 3 different methods that we use. And one thing to keep in mind is that if the dividend is 0, then the quotient will be 0. Like if you had a 0 there instead of a 24, 0 over 3 would equal 0. If the dividend is 0, the quotient will always be 0. And then another thing to remember is that the divisor can never be 0. So remember that, especially the divisor can never equal 0. Why don't we do a few division problems? Let's do one dealing with money. Let's do $7.35 divided by 5, and we'll use our long division format to do this. Now if you remember, this should be a review. Division should be a review for you. You put the decimal for the quotient, you put it right above the dividend's decimal point. And so we think to ourselves, how many times can 5 go into 7? It can go into 7 one time. And so we do 5 times 1 is 5, and bring that down, and subtract. 7 minus 5 is 2. And then bring a 3 down, we have 23. And then we say 5 can go into 23 4 times. And so we do 5 times 4 is 20. Subtract those two. 23 minus 20 would be 3. Bring down the 5. 5 can go into 35 7 times. And so we're done then, because 5 times 7 is 35, and we'd have a result of 0 there. And so our answer, let me just write it over here, $1.47. Now if you look on page 9 in your book, they talk about a short division format as well. I'm just going to do these problems using the long division format. If you want to do the short division format and study that and learn that, then by all means do that, but I'll just do these problems using long division. Let's do a couple more division problems. Let's do this one. Try this one. 144 divided by 12. Now maybe you already know the answer to that because you know that 12 times 12 equals 144. And that's an interesting thing in multiplication. When you multiply your quotient by your divisor, you get back to your dividend. Let's just go ahead and do long division on this, even though we've already discussed the answer. And we'll see that the quotient is 12. 12 goes into 14 one time. So that 14 minus 12 would be 2. Bring a 4 down. 12 goes into 24 exactly 2 times. And so this would be 24 here. And the remainder would be 0. And so our answer is 12. And just like we said, you can multiply the quotient by the divisor, 12 times 12, and you get back to your dividend, 144. Let's do another one. 84 divided by 6. Let's try that. Okay, maybe you could do that one in your head as well. We'll just do long division. 6 into 84. 6 goes into 8 one time. So 6 times 1 is 6. Subtract those. You get 2. Bring down the 4. 6 times 4 is 24. So we'll get a remainder of 0 again, and so that's our answer. 14 would be the answer. Well, let's do another problem, and this will be a problem dealing with the definitions of the parts of a division problem, and which numbers in problems D, E, and F, we have all those on the board there, which numbers are the dividends in those problems. Now, if you don't remember what the dividend is, on page 8 in your book, there's a little boxed area that shows you what the dividend is. And notice these problems, we've done long division on all of them. So what part of that long division problem is the dividend? That would be inside that long division symbol. So we'd have $7.35, 144, and 84. Those would be our dividends. And so that's our answer here in G. $7.35, 144, and 84. Okay, let's look at the last part of Lesson 2 on fact families. Remember, we did these fact families with addition and subtraction in Lesson 1. And we would have 3 numbers, and we would make 2 addition facts and 2 subtraction facts with those. We're going to do the same thing here, except we're going to do 2 multiplication and 2 division facts instead. And the reason we do this is just to give you an idea of how these numbers relate and how addition and subtraction relate, like we did in Lesson 1, how multiplication and division relate. That's what we're going to do here. So let's do a problem. And let's use these 3 numbers, 6, 7, and 42. And let's make 2 multiplication and 2 division facts with these numbers. Well, 2 multiplication facts, we could do 6 times 7 is 42. And then we remember that the order that we multiply numbers in does not matter. So we could do 7 times 6 is 42 for the other multiplication fact. Now division, let's use the 42 as our dividend. We'll use the big number as our dividend. 42 divided by 6, that equals 7. Remember, we were saying earlier that you can multiply the divisor, which is the 6, by the quotient, the 7, and that gets you back to the dividend. 6 times 7 is 42. And so our other fact family, our 4th fact family, is 42 divided by 7 equals 6. Now I'll remind you again, like I did at the end of lesson 1, I don't do the same practice problems that are in the book. I do similar ones, but I don't do the same ones. And like practice problem H that we just did, that's similar to practice problem H on page 10. Okay, well that's all for lesson 2.